That is what AAA does. All right, it's worth it. Okay, and you get discounts other places when you are a AAA member. You do. All right, so David was right. When you read this scenario in part A, you should be thinking tree diagram. That one tree thing, that's One Tree Hill, right? That show. Do you really? Oh my God, I figured no one would know that show. Okay, so let's do the first part of the tree diagram. This I'm going to do is the disease part. So I'm going to say disease, and then I'm going to say no disease. So what percentage of the population has the disease? No, it tells us. Hopefully not, right? Otherwise we'd be dead, right? 2%, that right there, it says the disease occurs in 2% of the population. So I'm going to say this is 0.02. So then what percent of the population doesn't have the disease? 0.98. All right. Then from here, I'm going to have where they're testing, right? They're testing positive or testing negative. Positive, testing negative. Do I have permission to scare you? That's what I have to ask before I do it. Okay. I don't want someone dying. All right. So the first part says the laboratory test for the detection of a certain disease gives a positive result 5% of the time for people who do not have the disease. Ready? So they don't have the disease, and the positive test result is 5% of the time. So what am I going to put for they don't have the disease, but they're testing negative? 0.95. Okay. The next part says the test gives a negative result 0.3% of the time for people who have the disease. So this is going to be 0.003. Just be careful on that. I've seen students do this problem where they forget to move it over because it already is a decimal, right? 0.3%, but as a decimal, that's 0.003. So make sure you're just careful with that. Okay. So then what is going to be my other part of that tree or that branch? Nice. 0.997 is correct. Remember when we did this before Thanksgiving, I'm going to travel across the branches. And what operation do I use as I travel across the branches? Multiplication. So I'm going to write down probability of disease and positive. Probability of disease and negative. Probability of no disease and positive. Probability of no disease and negative. Okay, so let's multiply. 0.02 times 0.997. That's 0.01994. Now, guys, remember when we did this, don't round, right? Don't round right now. We're not actually doing the problem yet. I know we're doing the problem. I'm not getting an answer yet, so please don't round. 0.01994. 0.02 times 0.003. So this is, so if you're having trouble with this, because David said E, right? So this is 6 times 10 to the negative fifth power, right? That's what that's saying. So you're going to move it over 1, 2, 3, 4, 5. So you have 1, 2, 3, 4 zeros after the decimal. It's just called scientific notation. 0.98 times 0.05, 0.049, and then finally 0.98 times 0.95, 0.931. Now remember, I'm trying to go fast here so you guys have enough time to practice, but one thing that I would recommend doing is after you get all of these, you should add them up, and what should they add up to when you take all of them in your calculator? 1, right? If they don't, then you made a mistake. So maybe, especially if you're doing one with scientific notation, right, maybe it's a good one to do because maybe you have like not enough zeros. Maybe you forgot a zero or did too many zeros with that one. Okay? All right. So the first part A says, what is the probability that a person selected at random would test positive? So testing positive. So do I care if they actually have the disease or not? No, I do not. So there should be 2 of these that have the word positive in them. Does the first one have positive? Yes. Does the second one have positive? No. The third one? Yes. And what about the last one? No. So just these 2. So add these 2 together. Did I forget a 0? I did. See, look at you. Well done. And your hiccups are gone. What a day. .06894. 0.06894. Now, if you want to round from here to write 0.069, that's totally fine. You'll notice the reason I'm going to write this all out first without rounded is because part B is going to ask me to use this. Okay, so I would just recommend you can round for the answer, but have the unrounded one ready because you might need it for a later part. Yes, so what is the probability? If you wanted to write a sentence, you would say the likelihood that a person selected at random that would test positive for this disease is approximately 6.9%. You do not. It just says, what is the probability? Do I have the probability? I do. Okay. Part B. Part B says, what is the probability that a person selected at random who tests positive for this disease does not have the disease? So the way that I read this, the way that I said it to you, was I'm hoping that you'll think either one of 2 words when you read part B. No. One of the words starts with a G, or the other one I'm thinking starts with a C. Somebody said, kind of. Conditional probability, right? This is a condition. Or I always think the other word, G, one of these is our given. One of these is our given, right? What are they telling me has to be true about this person? They have to test positive. No, they could, right? Or sorry, let me start with this. At first, I don't care, right? They have to have a positive test. So I would write positive. Remember that little bar? It's this, yes. So the given is positive. And then, Jade, you're right. Once I look at only the people that tested positive, what's the likelihood that I select a person who doesn't have the disease? So I'm going to put no disease here. Now I'm going to write on the board, right, before you practice here in a few minutes, right, this formula. It will be given to you on the AP exam, right? But the way to do this is your given, whatever they tell you is your given, that's always your denominator. So my denominator is going to be the probability that they test positive, which you take a moment to think. I know you guys are writing furiously. You take a moment to think, what did we find in letter A? We found that, right? So what we found in letter A, and sometimes the AP exam is trying to be nice to you, right? If you did all that work in part A, at least now you've got a continuation here in part B. So my denominator is what I found in part A, okay? Now, on top is where you're going to say both of these happened. So no disease and they tested positive, which I believe should be something that we calculated, even though we didn't necessarily focus on that in part A, it's in our tree diagram calculations. So my denominator, again, not rounded, is 0.06894. And my numerator is which one was my no disease and positive? No disease and positive is my third one, right? So 0.049 is my numerator. Okay, great. I look forward to looking at your scores in July then. So 0.711. So essentially, if we know that the person tests positive for the disease, the likelihood that they would not have the disease and test positive is 71%. That seems quite high.